Okay, so we're talking about slopes, but we're also kind of talking about equations of lines too, but it's how the parallel and perpendicular slopes affect those equations of lines. So the first thing we're going to do is just look at this and say, it says parallel lines have, and then it's the same slope. So essentially, if you can identify the slope of a line, then you can solve, okay? So y equals mx plus b form, our m is going to be our slope. So that is going to be 2. And then parallel lines have the same slope. So the a parallel line would have, to this line, would have a slope of 2. Okay? And then the next thing we're going to do is, well, what if it is not in standard, or it's not in y equals mx plus b form? It is in standard form. So these coefficients in front of it, or the number in front of this is technically like ax plus by equals c. So like the number in front of y is 1. So a is 4, b is 1, c is 2. And when we get to the next page, I'm going to show you a shortcut for this, but I'm going to show you like the long way first so you understand the math, and then I'm going to show you the shortcut. You can't always do the shortcut, but when you can, it's nice. So let me show you this way first. We are trying to get y all by itself. So we need to ultimately switch x to the other side. So I need to get my x, 4x over here. So I've got y on one side, and then I'm going to have my equal sign. And then I've got negative 4x plus 2. Here's what throws everybody off, is they want to like somehow combine these. You're just putting them next to each other. You are taking this and you're switching it to the other side. But in order to switch it to the other side, you've got to change the sign. Okay? So your m is going to be negative 4. All right, notice it is not the same like as a right there. The a for standard form, or the coefficient, the number in front of x, is a positive 4, but the actual slope is a negative 4. So just make sure you guys see that. Like, that's something that people get mixed up. They're like, oh, it's just the number next to x, and they put 4 and then they get it wrong. So you've got to move it to y equals mx plus b form. All right, we're going to do the same thing, y equals mx plus b. So we're going to take the 2x, we're going to put it over here, and we're going to change the sign. So it becomes, bring my negative 3y down, and this is negative 2x plus 6. All right, so everybody see what I did? I just took that 2x and I made it negative 2x. And then now I'm still not done. Negative 2 is not the slope because it has to be y equals mx plus b. So this is where it gets tricky, and this is the thing that's new today. So we've got to get that y equals mx plus b. We've got to get the y all by itself. So I'm going to divide by 3 on one side and then divide by 3 on the other side. But it looks weird. Or, sorry, divide by negative 3. Because you've got to divide all the things. There's a plus sign here, so you can't just divide that whole thing. Divide them separately, because that plus sign separates it. So this cancels. It becomes y equals, all right, we've got negative 2 over negative 3x. And just remember, if you have two negative signs, what happens to them? Yeah, it cancels out. Perfect. They become positive. So 2/3 x plus, and then 6 divided by negative 3 is a negative 2. I shouldn't have put a plus sign there. I should just say minus 2. All right, so my slope for this is 2/3. All right, so perpendicular slopes have opposite reciprocal slope. All right, they're the opposite reciprocal. Or you change the sign, change sign, and flip. That's how I like to say it. Change the sign and then you flip it. Okay, so what does that look like? So if my normal slope is m and my normal slope is 5 and my perpendicular slope is going to be a different sign, it starts as positive, my perpendicular one's going to be negative. And then this one just throws people off a lot of times because they look at 5 and they're like, how do you flip it? Like, what does that even mean? Well, any number can be above 1. So 5 is 5 over 1. 10 is 10 over 1. 17 is 17 over 1. It doesn't matter. It's no different. You can flip those, and make it 1 over 5. So anytime it's a whole number, just make it 1 over that number. All right, so negative 1 over 5 would be the perpendicular slope to that. All right, I'm going to do this one, and I'm going to give you guys a chance to do these last two. I'm going to pause it. So my perpendicular slope for this, it's going to go from negative to positive, and then I'm going to flip it. So it's going to be 2/3. All right, so I want you to pause the video, do these last two, and then look at the answer. Okay, so here are the answers to these. 1 over 10 and negative 4. And that's how perpendicular slopes work. Okay, so we are going to graph two lines. There's a parallel one and there's a perpendicular line. We need, so for parallel, it's going to have the same slope. So this one's kind of interesting because you are going to graph, you just pick any line literally anywhere, and you are going to graph a line that is parallel that has a 0 slope. So this slope is m equals 0, just like this one. So this one is parallel. What? So like the slope is going to be m equals 0. The actual equation of the line is y equals wherever it is. So like in this case, it'd be y equals 3. But it just asks, it doesn't say, you know, write the name of it. It just says graph the line. And then a perpendicular slope to that one would be a vertical slope. So you can kind of pick wherever you want it. So this one, I'm going to draw it at x equals 4. It's an undefined slope. And I also put this one on here to show you the difference between a 0 slope. So a perpendicular slope would be at a right angle, and if 0 is the slope, then the undefined slope is going to be perpendicular to it. There, I'm saying words that don't make sense. So if a problem ever gives you a line with a slope of 0 and then asks for the perpendicular slope, that slope will be undefined, and I think that really throws people off sometimes. Okay, so hopefully that is helpful and kind of gives you a picture of what's going on. Now we need to figure out the slope here, and it's actually fairly difficult because there's no lines. But the slope here is going to be -1, all right? My slope is -1. How do I know that? Because, well, for one, it crosses here at 4, and then it crosses again at 4, so it goes down 4 over 4, so that will simplify to -1. It's really hard to tell without a graph, though, so I'm just going to give that to you. So our parallel slope would be just another line with a slope of -1. So I'm going to have it cross at 1, 1, and 1, 0, to where it still has that -1 slope, but the line can be anywhere. So this is going to be the one that's parallel. And then the perpendicular slope is going to be a slope that is a positive one. All right, so any slope that goes up 1 over 1, up 1 over 1. So an easy way to do that is to draw a line, or draw a point at like -3. And then if I go up 1 over 1, up 1 over 1, 3 times, it's going to pass at 3. Another way I could see that is it goes up 3 over 3. 3 over 3 simplifies to 1. So this line is going to be perpendicular to the other two that we've drawn. And the way that like Delta Math works for these is that it'll just have you draw either or, not both. But for the notes purposes, I had you draw. So this is standard form, and then make sure you write that helpful hint. The x has to come first. If these are switched around, you got to switch them back. I'm going to show you the shortcut this time, because on the first page we showed you the long way, where you move x over and then you divide. But on this one, here's what the shortcut is. So the slope is going to be -a over b. So this is my a, this is my b, and that's my c. So -18 over 15 is going to be my slope. And we're going to simplify that. Remember, you can also do that in the calculator if you need help simplifying. But both of these divide by 3. So -6 over 5 is what that simplifies to. Divide both of them by 3. And only one of them's negative, so it remains negative. So this is the parallel slope. This is what the m is. M equals negative 6 over 5. This is parallel as well because, you know, the slopes are the same. We have found the slope of this line. Now we need the perpendicular slope. So our perpendicular slope would be flip it and change the sign. So it goes from negative to positive. It goes from 6 over to 5 to 5 over 6. All right, so now I'm going to pause and have you try this next one. And then it switches to 5 over 3. Why does that happen? Because it's a negative over a negative. All right, so the actual slope, or the slope of the parallel line, is 5 over 3. And then if we change it to the perpendicular slope, you're going to get negative 3 over 5. So our two slopes are 5 over 3 and negative 3 over 5. This is the perpendicular one. This is the parallel one. Okay? And then this last one is negative 3 over 3. That simplifies to negative 1. So our perpendicular slope would be a positive 1. Okay? All right, so we're going to circle one of these based on these lines. So I've got to figure out what the slope is. Okay, if my slope is negative a over b, here's one where the y is in front of the x. We've got to switch that. This is my a, and this is my b. You'll see that? B and a. This is what I was talking about. So negative a would be a positive 4 over 6. So that would be 2/3. That is my slope. All right, there's one slope. That's the slope of this line. Negative 2, or positive 2 over 3. For this is, oh my goodness, is that a plus sign? I think it's a plus sign, but it's actually really hard to tell. It may not be. I don't think it is. It just kind of looks like it is. So positive 2, because it's, the formula is negative a over b, over 3. Ooh. So these look like they are parallel, but what you have to do is you've got to go back and you've got to figure out, is it the exact same line? So if it's parallel, you have to go back and do this last step. If it's perpendicular, or neither, then you don't have to go back and do this step. But we have to solve these equations and figure out, are they the exact same line? So 6y minus 4x, we're going to move the 4x over. 6y equals 4x plus 12. And then we're going to divide by 6 on both sides. So y equals 2/3 x plus 2. We're going to do the same thing for this line. We're going to move this over. 3y equals 2x plus 21. We're going to divide by 3. Y equals 2/3 x plus 7. Are these lines the exact same? When you look at them, do they have the same y-intercept? They don't, right? So this is the same process that we went through earlier. The only reason we're doing this is because they're parallel. If they have different slopes, they can't be the same line, so we can just move on. But if these lines are parallel, you have to check and see if it's also the same line. So parallel, and then we circle it, and we move on. Okay, so figure out these slopes, pause the video, and I'm going to uncover this. Okay, those are the two slopes, and then those lines are going to be perpendicular. Let's do this last one. So we have y equals negative 5x equals 5, and then we have this line over here. So negative a, this is my a, that's my b, because whatever's next to a. So it's a negative 5, we're going to turn it into a positive 5 over 1. So my slope is 5. The slope here, positive 20, I don't know where the 5 came from. 20 over 4. Where are these numbers coming from? It's negative a, so it goes from a negative to a positive, over b. That simplifies to 5. Okay, there is the same slope. So let's do this one more time. Let's solve these out and see what we get. When you put both of these in y equals mx plus b form, they end up being the same line.